the National Science Foundation program to the final company developed or spin out is about 10 years time. And the EM sensor is a non-destructive testing technology. We use that to measure the stress, not the strain, okay? The stress and then the corrosion or the force of the steel. All right, so it's an electromagnetic sensor that non-contact, and the magnetic sensor does not touch the specimen. Actually, it's just magnet to produce that. All right, so based on the property of permeability, which is meaning your excitation and your induction and the slope in between, that's called permeability, and your driving force, which is your primary force, and there is a certain linear relationship in between them. In the lower induction, in the lower induction force, then you have more very sensitivity very high, but it's not very linear. But in the very later on, you have very linear related to your stress and also to your stress to your permeability. And the sensor actually is you have a primary coil, and then you have a secondary coil, and then you have a protection mechanism over here. And coming up to the equation then is very simple. Your permeability is related to your stress, your temperature, and your introduction force, okay? Your primary force, magnetic force. And as you can see, there are so many different kind of cable. So we calibrate all these cable related to their different type. You can see gradually from the smaller and the very smaller and also larger size, they all fit into very linearity curve up to about 60% of their yielding stress. All right, so here I'm talking about this. From the very early development, you can see all different sensor size, and we even have to develop our own box and electronic. And so we don't have anything else to helping us except the voltmeter. And so from there, we had to develop all the electronic for many years. And eventually, you are smoothing out, and you have a very good sensor size being developed. Some of them are very small. This one used most frequent. And then we have a larger size for large cable. And this is the box that we use to generate the magnetic force and also the products. Okay? And actually, the sensor can manufacture in-house. And you can see here is mass production, okay? And also you can manufacture in the existing cable. It's very important application because most of them are in the existing cable. And as you can see here, it's a mass production. So here, from here, you can also do the calibration, packaging before you ship to the site. So those kind of business that you need to think about when you develop a certain sensor. How are you going to do that in a kind of company setup, in a kind of application setup? And so that's another example of mass production of this sensor. Look quickly. I don't want it to be too specific. But we have to use this, we currently use this a lot in the kind of retaining wall or the stability for the earth foundation and reinforcement because it's very hard to use in vibration method. Okay? So you see this is in Canada, we apply them into a dam, and from the dam you try to find out the stress in a dam. And this is another example in the largest dome in Japan, and they put 270 sensor, EM sensor into this to help during the construction to erect them uniformly. And this is a box girder bridge. Inside the box girder, you can see a lot of cable here, and then you put your sensor over there to monitor the cable force. All right, so this is the largest cable stay bridge in Hong Kong here that use the sensor in their box girder to monitor their box girder post-tensioning force. And this is the one very near us in Water Bridge near Ming. They use this EM sensor during the construction to calibrate one by one post-tensioning process. And so many usage. I'm just flip them around. And this EM sensor used for existing cable in Taiwan, and this is another one in Japan, and for arch bridge. And so there are so many until at this moment we have about 50 to 60 projects using these products so far. Okay, so then most of the time people ask me a question: how can your sensor compare to most frequently used vibration frequency approach. You can measure your vibration frequency through their frequency analysis. You can really roughly predict your stress. Can you do that? Most of the time is, I tell them, if you have a longer cable, fine, you can go ahead and do a good calibration. But if you have a short cable, or you have a cable grouted, most of the cable you grout them for protection from corrosion, then if that's the case, you use this EM sensor would be the best.
I've been involved in sensors since 1982. Probably in this room, maybe very few people have been involved in sensors that long. And my involvement started as a PhD student. I will get to that a little bit later. Even though I'm not doctor yet, I had to start up my company instead. I had to sacrifice to get my doctorate. Going back to the Dr. Ming Wang's research in the paper, when I found out about this sensor, one thing that stood out was that a lot of sensors you have to embed it. You have to embed it into the concrete, you have to embed it into the structure. Dr. Ming Wang's sensor, they have these clamps, like a U-shape or two semicircles where you can clamp it onto the cable. So it doesn't have to be inside the cable, which is a big advantage. So that means you don't have to worry about building a new bridge with the sensor inside it. Most sensors are like that. But Dr. Ming Wang's sensor, existing buildings, existing structures, you can use it. That's the big advantage. And also, I was impressed with the resolution, the accuracy. So I'm proud to say that it's a very interesting sensor. If it is marketed properly, it could make a lot more money for him or for the university, whoever supports him. Now, regarding my experiences in taking the university research into business, maybe I should get PhD on that, because I started my business based on my PhD thesis, and then after I started the company, I took turn over 2 technologies from different universities into commercial successful products. And there are a number of things that you have to consider when you start the company, and when you are somewhat successful, what you need to do in your exit strategy if you have any. One of the most important things when you start up the company is to believe in that you have a product that will have a commercial application. So obviously you have to talk to people and see what the applications are, and also try to avoid single customers or handful of customers, because if you have like 4 or 5 customers who are going to buy your products, that's big risk. You want to make sure that your product is sold into as many customers as possible, preferably as many different fields as possible, not just medical or military or whatever, because then you limit your success. Also, try to close your ears to naysayers, because when you are starting business from university, there will be 1,000 naysayers, only one supports you. If you really believe in it, you should learn to sacrifice. I sacrificed my PhD thesis. I was in the middle of writing it. I actually wrote 30% of it. But timing is everything. So if I waited till I finished my PhD, I wouldn't be here as a successful businessman. I would be here as someone with a doctorate degree, which is not bad if that's what you want to do.
He's a professor.
Or a professor. Actually, everyone was shocked that I started a business, because when I always grew up, I always wanted to be a researcher or a professor. But what drove me into business is because somebody told me I cannot do it, and I just wanted to prove to them that I can, so I did. So when you start up the business, 2 mistakes I made. Everyone makes mistakes. I made 2 major ones. I knew we had a good product, and having a good product doesn't mean that you're going to be the best. I realized that 5 years later, because a lot of successful companies in the world don't have the best product. They just have the best people. So you have to make sure that you surround yourself with the best people. Have a good product, good enough product. And also learn when to get out. In my case, I could have gotten out in the peak of the heydays, 2000. I was a paper billionaire. I was in registration to go public, but the elections in U.S. Reduced our valuations by half. So the greed factor comes in. My advisor said, wait. I wanted to go public a little bit earlier. I'm still waiting 10 years after. So if I sold the company, and we had a lot of offers too, I would have bought the company back 50 times less value a couple of years later. So I wasn't greedy then. Maybe that's probably why I didn't sell it, because I was young. I was 40 something, and so learn when to get out. Okay, that's another mistake you have to learn. Now, in terms of the things that you have to ask also in terms of the technology that you have, is that you have to learn to spend a lot of hours next 3 to 4 years, possibly 5. That means 60 to 80 hours a week. So this is not like Wall Street where you make money and retire 2 years later. Most businesses work very hard to be successful, unless you're in Wall Street. But it's not like the movie Wall Street. You have to work hard, okay? And you have to also sacrifice. Like in my case, I sacrificed a very good job. Actually, I was offered $70,000 in San Francisco. My wife said, take it. 2 years later, go back and start it. I said, I can't. Because the difficulty most of you guys are gonna face if you have a certain standard of living, because when you start your business, your living goes down, way down. Because you work longer hours, you don't get paid. Because if you get paid, the company runs out of cash. So, and you have to have a good family, or don't get married till you are successful.
What drove the business? Was it regulatory or some other incentive?
Market. I mean, if there is a market, and there is a big market out there, we've been talking last 10 years about smart things because of the development in wireless technology and computers. Now, you can put computers and wireless into the sensor built in and transfer the information anywhere in the area, depending on how strong the wireless signal. If you use a cell phone or satellite, you can remotely access any of these points anywhere in the world. So obviously it has numerous applications, not only in health monitoring, because my interest came from the corrosion of pipelines, because we have sensors that we sell to oil and gas people, which they have a lot of money available to buy these innovative sensors. So, but then I looked at the smart structures. Yes. Now we're talking about like smart buildings. It is a reality, just like smartphones. 10 years ago, people wouldn't believe there would be smartphones. You have smartphones now. You will have in 10 to 20 years smart buildings, smart structures. Sensors like Dr. Wang's will allow us to have a low-cost monitoring of buildings and highways or structures.
So I'm sorry, just to follow up. Is it the contractor of the building who wants to put these in, or is it the building code? The local or federal authorities.
That's a very good point, guys. And the big void that I see in the sensor market, every time I go to these conferences, and it shows that there is a very good papers, very good technology, but the problem is you don't see the contractors being here, or the building regulators. I think that what I like to see, or insurance companies, for that matter, they want to put it in the code that forces the contractors to put it in there. So as far as the contractor thinks that unless they're forced to do, they don't want to do anything. They make money anyway either way. What's the purpose of them putting it in? Yes, it will save lives, but then if the government says or regulation says that you have to put it in there, they're going to say, oh, okay, I'll save lives and I still make money. But it is important that the insurance companies and the government should come in and make it almost mandatory to put them, because otherwise you're not going to get the participation of the contractors. Very rarely.
In health monitoring, it's not like a regulatory or a code. Most of the time it's from the designer or owner, their requirement. It is a new market in reality.